Okay, welcome back to Breckenridge, to the Glenn Gerberg Weather and Climate Summit. This is a special part of the Weather and Climate Summit where we include the online internet audience to be able to ask questions of the speakers from this morning. So to my left, we have Jennifer Francis, Dr. Jennifer Francis from Rutgers University, who you may have just seen speak about Arctic sea ice and changing of synoptic weather patterns. And to my right is Dr. David Novak from the Hydrometeorological Prediction Center. And so we're going to get started right away, and depending on how many questions we have, we'll go for 30 minutes or a little bit longer or shorter. We'll just see how it goes with the internet audience. Okay, so I'm just going to walk over here to Sarah, and we'll take over the microphone to her so she can ask the first question.
Okay, welcome. This is for Dr. Francis. How do on-air personalities share your info in a way that is not viewed as pontificating or offensive to the ostriches or people who prefer to bury their head in the sand, so to speak?
So I had a little trouble hearing you, Sarah, but you asked how the TV meteorologists convey the uncertainty in some people's perception of human-caused climate change?
Yes, I think this particular viewer is interested in how people in the media are able to discuss the topics you were talking about today and reach the people who maybe are not believers, a little skeptical. Do you talk a lot to the media on how they can communicate this information in a way that people can be receptive to it?
Yeah. Well, I think, part of what we tried to do was we had an idea of how the changing Arctic was going to affect mid-latitude weather patterns. And so we looked to the observations or the reanalyses, or which are very close to the observations, to try to illustrate how the real world is behaving according to this theory of the relationship between the Arctic and mid-latitudes. And so, we provided actual evidence from the real world. It's not a model. It's not, something that we drummed up. So I think, the concepts are actually relatively straightforward. And if people understand how a jet stream is created, the fact that it requires this difference in temperature between mid-latitudes and high latitudes, and if that temperature difference is getting weaker, then it's a straight connection to how the jet stream is weakening. And so I think there are ways that we can help the public understand a relatively complex behavior, but in relatively simple terms.
Great, thank you. Okay, this question is for Dr. Novak, and this comes from Craig in Canada. You made an excellent presentation at the AMS meeting about Sandy. Were any lessons learned there, and any considerations of additional rainfall and snowfall-based products for tropical cyclones and improving threat awareness?
Well, as you're aware, the Surface Assessment Team is actually, as we speak, ongoing their work, taking a look at, in detail, the variety of services that the Weather Service provided. So I'm sure there are plenty of lessons learned. It was such a unique event, such a historic event as well. And so I think really for the Weather Enterprise, we were doing the best we could with the tools we had at the time. And I think as explained at AMS, I think we really did save a number of lives and property with this event. In terms of the precipitation aspects, the accuracy of the forecast, really in general, the accuracy of the forecast was exceptional for Sandy. Perhaps there are improvements in the messaging and communication where we can get folks to react even more strongly, evacuate when they're asked to evacuate. And I think that's a lot of where the focus is turning, as to how can we best, if we have this accurate information, how can we best communicate it in a way that individuals can relate to their decisions that they're making and mitigate their losses. And ultimately, in some of these cases, save their lives. So I think it has to do with the communication aspect. I think that's where the Weather Enterprise, I think, is focusing some of the improvements.
Thank you. This again is for Dr. Francis. Have any municipalities reached out to you regarding any of your work, especially sea level rise, or agriculturally, talking about adapting to sea level rise with infrastructure, construction, or farmers, mariners? Do you have folks like that reaching out to you about your research?
I have had a lot of inquiries from people all over the place, actually, and I don't deal too much with sea level rise per se, but the connections to weather and changing weather patterns in their locations in different seasons that they have observed and experienced and wondered whether it might be somehow connected to Arctic change or to climate change in general. And so, yes, I have talked to farmers in Colorado, as a matter of fact, and their curiosity about the drought and whether it was potentially going to increase or continue, and whether they were going to get a snowy winter. And because I live on the coast up in New England, I talk to people all the time about changing winds. I'm a sailor, and the sailors are always wanting to know, why didn't the wind blow its normal way this summer? And so, you know, people are really starting to increase their conversation, I think, about some of the things that they're observing in their own lives, in their own regions, and wondering whether there's some connection to climate change. And so I think there's been a huge uptick in these kinds of conversations all over the place.
Okay, and again for you, Dr. Francis, can you summarize the advances you've made since this last year on your research? What's the new data that reinforces the information that you've collected over the past year?
I think there's several different things that we've been doing this past year that seem to be all consistent with our original hypothesis. One is this new measure that we've come up with to try to figure out whether, in fact, the waves in the large-scale waves in the atmosphere do seem to be slowing down in connection with Arctic amplification or not, and I presented some of those results today, even though they're really quite preliminary. The other thing that we've been trying to look at is whether the atmosphere really is becoming more wavy, and this is this meridional circulation index that we developed that is really just a simple measure of the wind directions in high levels, and whether they're becoming more north-south, as they should if the wind patterns are becoming more wavy. So those two things I think are helping, and they're consistent with our hypothesis. And we've also started looking at output from global climate models and their projections for the future, and to see whether the tendencies that we're seeing in the real world seem to be continuing into the future, and whether the models are actually able to capture the kinds of changes that we've been able to observe in the real world.
Thank you. Okay, Dr. Novak, your talk today was about extreme precipitation events. Do you want to talk a little bit more, maybe elaborate on how HPC is adapting to the larger number of extreme precipitation events, and how it might change your product creation and dissemination?
Well, I think in the presentation we talked about some of the enhanced services we're providing, particularly in the probabilistic realm. And so, in respect to, for example, the probabilities of these very high rainfall amounts is a new product that we're providing, the probabilistic QPF, for example. And the 95th percentile of the distribution we talked about. These reasonable worst-case scenarios are a way of communicating the risk of these increasing extreme events. We also talked about this morning this kind of focus on the very short term, the kind of 1 to 6 hour forecast range, of where we think HPC can provide an enhanced situational awareness to both forecasters and the media and the public of where exactly the threat is emerging, what part of a state is really going to be under the gun in the next few hours for these extreme events. So it's certainly been an interesting decade, and there's been a number of flash flood and flood events, as you're aware, that have affected the nation. And so I think we are continue to adapt with our product suite, as well as I was mentioning, with how we're communicating the risk of these extreme events without overhyping, while still getting the message that there's a risk of a significant event. So it continues to be an emerging area.
Thank you. Okay, Dr. Francis, Near the end of your presentation, you made a reference to the word not getting out to the people that need to hear it, and a reference also to misinformation that's being presented. Can you be a little more specific and elaborate on your feelings regarding that issue?
Right. Well, as we all know, there have been organizations out there who have deliberately tried to cover up the evidence of climate change. A lot of money has gone into trying to put out information to confuse the public about the causes of climate change, and they have been very effective. And I think that the people who need to hear from scientists what the real story is, and in fact, you know, scientists have been putting out information based on scientific studies, peer-reviewed studies, and this is the kind of information that has been it has been the subject of the disinformation, I would say. And so the public, rightly, has been very confused because they've been getting different messages from different organizations and they don't really know what to believe. And of course, you know, the specter of climate change is not a happy one in general. And so people, you know, if there's any doubt, then they would rather believe the story that isn't quite so discouraging. So, but I think the public is very intelligent. They're starting to see with their very own eyes that extreme weather is increasing. It's happening to them. It's happening to people they know all over our country and other countries. They're seeing other evidence for climate change, like disappearing sea ice, and they're putting two and two together. They're realizing that the disinformation that they've been served has basically been to try to manipulate them, and they're realizing that, yes, there is something serious going on here and that, that humans really are affecting our climate system and we really need to take some action.
Great. Okay, this is for Dr. Novak, and this might be a little bit outside of your expertise, but I'm going to throw it out there anyway. Is there any work being done specifically to improve forecasting capabilities in mountain terrains, you know, I guess related to precipitation events as well? It is the viewers' understanding that some of the radar issues, that there are radar issues and other topographical challenges. Are there technical challenges as well, and what is your reply to that?
Yeah, the West is complex. I mean, I can look out the window here and see all the different ridges and details that can be difficult for models to capture. But the good news is a lot of the predictability of the West is related to resolution, how fine of scale of resolution of forecasts that you're making. And so through these investments in our NWP infrastructure, we've been able to reduce the resolution of our models down to, you know, roughly these 1 to 4 kilometer ranges, or roughly, you know, 2 to 3 mile type range. And we're starting to get, you know, this nice detail in the West with precipitation. For example, with some of the bigger slopes, you might find that the heavier precip isn't necessarily at the top of the mountain. It might actually be on the windward slope. And that depends on such things as the stability and other aspects. Or it might even be a little bit upstream of the slope. Or it might even be, you know, on the edge. And so these fine-scale details of the flow, the stability, now that you're resolving those, you can really start to get at the particular details of exactly where the heaviest of the precip will fall, what particular ranges and sub-ranges will be affected. So at HPC, we are working towards increasing the resolution of our QPF products to better depict what we're seeing in the model guidance and to provide that to you, the customer.
Wonderful. Dr. Francis, this comes from a viewer, and half jokingly but half serious, your work has been very high profile lately, and you are gaining a lot of attention for your topic. Have you considered maybe a position maybe with the EPA?
Well, thank you very much for that. I have not considered a position at the EPA. I like my position very well the way it is. I really like doing my research, and I am probably going to stay pretty much the way I am right now.
This is Dave Jones with Storm Center. This is for Dave Novak. Was just wondering how in the Weather Ready Nation initiative, what kind of steps is HPC taking to make sure that HPC is contributing to the Weather Ready Nation initiative?
Yeah, sure. Actually, on our homepage, we have our strategic plan for the next 5 to 10 years, which is closely related to the National Weather Service Weather Ready Nation initiative. And it includes some of the things we talked about this morning, becoming a leader in the probabilistic information, learning to better communicate and provide decision support for our partners and customers, both extending the range of our forecasts, such as the 7-day QPF forecast, as well as providing that more detailed information at the shorter ranges. So I think it really does fold quite nicely into the decision support focus that you see in the Weather Ready Nation, as well as the improved science and services that you see in the Weather Ready Nation initiative. So again, that's right on our homepage at the top. You can read more details there.
That's great. Just a follow-up question to that, which is a result of some discussions around here from the folks that are attending the Weather and Climate Summit. There seems to be a lot more comparison now, even on the Weather Channel and in discussions out of the Weather Service, of various models. And the European model seems to be highlighted as, let's take a look at this, see what it's doing. They even compare it on the Weather Channel a lot. Here's what the Euro says. Here's what the GFS says. And it seems like the Europeans have an edge on numerical weather prediction. Where are we headed, or where does the U.S. need to head in order to either get to par with the Europeans or maybe start exceeding the Europeans in the quality of our numerical weather prediction products?
Right. So just as a preface here, it's hard to make direct comparisons between the European Center, for example, which is focused on the medium range problem explicitly, versus the INSEP organization, for example, which has a whole host of a variety of requirements, from ocean modeling to hydrologic to the atmospheric aspect. So that is one aspect. But it is true, and as the National Academy of Sciences report Second to None pointed out, that the U.S. is falling behind when it comes to NWP, and part of that has to do with, well, a large portion of that has to do with our investment in our computing resources. And so, I think in NOAA we've been pushing that issue, and I think the weather enterprise itself is beginning to recognize that is a area of investment that perhaps we ought to improve, not just on the research side, but also the operational supercomputing infrastructure. There has been some investment in the research side, and there has been some improvements on the operational side, but to really become second to none, it'd be great to get a computing infrastructure that's, say, 100 times stronger than what we have now. That would really make us second to none.
Sounds great. Thank you, David. This question is for Jennifer. With regard to the research that you're finding, which has been fascinating, we've had a lot of online comments that your presentation was excellent, other people referring other people to go get the presentation and see it. But my question is about the folks in Alaska. As we see these high amplitude patterns happening, is Alaska, because of the melting ice, it's melting quicker, are they under new stresses because of these changes, and are they in a position where they can expect much more intense storm systems to affect their state?
Well, I think it's hard to pinpoint one location and say that any particular spot is going to get this kind of weather or that kind of weather, or what we're finding is that it's the jet stream in general, or the waves in general, are slowing down. And it could be that the North Pacific and the North Atlantic are particularly vulnerable to this effect because they're closer to where the ice has been lost. And so they're more susceptible to the effects of Arctic amplification and this weakening of the poleward temperature gradient. It also happens that the storm tracks tend to be very intense in those locations, and so it's not unreasonable to think that some of the changes that we see going forward are going to be felt most there in certain seasons, particularly fall and early winter. And that certainly seems to have been the case over the last decade or so, where it appears that the weather really has become more extreme. I know Alaska has had all kinds of events over the last few years in particular, with heavy snows and flooding and droughts in the summer and extreme fires in the summer. But you could say the same about the North Atlantic as well, particularly Greenland, and the UK certainly has been suffering its share of droughts and floods and snowstorms and really all kinds of wacky weather happening over there too. So I think it's very possible that those two locations in particular, and our evidence and our analysis seems to bear that out, that they will experience some pretty interesting weather as we go forward.
Has the oil industry been in touch with you about any of your research and what effect that might have in the Arctic area, since drilling is on the increase?
I haven't been approached by them directly. I have seen some references to our work in some documents that they have written, as well as the insurance industry seems to have picked up on this idea of increasing extreme weather, perhaps related to Arctic change. So the message seems to be getting out there, but so far they have not contacted me directly.
Okay. This question is for you, Dave, regarding all the changes that are going on in the Arctic. I know HPC does a lot of forecasting for the lower 48 and also Alaska and Hawaii. What kind of collaboration exists between HPC and OPC, which is the Ocean Prediction Center, to really provide the services that are needed for an enhanced marine environment, since so much is going on up there?
Yeah, the division of responsibility in INSIP lays that solely on the Ocean Prediction Center and the local WFOs in terms of the increasing marine space, right? I mean, as the Arctic sea ice retreats, you're suddenly finding open ocean, of course. And so as new industries start to build up there and shipping traffic increases, obviously there's a need. There's clearly a need for weather services in the marine areas. And that need is being addressed by OPC. In general, I would say that NOAA itself, I believe, has worked on some plans in terms of our services for the Arctic. Admittedly, I'm not particularly aware of the marine side of things, but I do know there certainly are activities. As it relates to on land, for example, which is where HPC plays a role with Alaska, we've increased our services in terms of providing medium-range forecasts for that region. We've also just recently acquired a compilation of polar orbiting satellite imagery in real time, so that you actually can able to see the Arctic from a satellite. Mm-hmm. So imagine all these polar orbiter satellites that you have. Just really recently, we've been able to working with our partners, kind of create a mosaic of all those different imagery, and then you can actually watch these systems. For me, it was really interesting because I've never really, I don't know how many meteorologists have really looked at a satellite animation, a visible satellite animation of the Arctic, for example, over the North Pole. And there's some unique cloud aspects and features up there that I think we're trying to get ourselves educated on in terms of just Arctic weather in general. Yeah.
So the OPC Ocean Prediction Center, if they have responsibility over the oceans, do they do forecasts like QPF, or do they, or is it assumed that people who work on the ocean, like drilling, that they won't care about precipitation? It's just really the wind and wave action.
More the latter. That in general, classic services are wind and wave forecast.
Okay.
Yeah.
I think, go ahead, Sarah.
Oh, I have one more just in. Dr. Francis, have you received any threats, or verbal or otherwise, in your area of work?
Thankfully, no. I've received some criticisms, some not so pleasant, but nothing really threatening, I'm happy to say, and hopefully that'll remain the case.
Well, that sounds terrific, Sarah. I'm just checking with you one more time to see if there's any more questions. And
I think we are finished, and I have many, many thanks from the online viewers for today's presentations. Everyone really appreciates you engaging with the public, so thank you both.
okay, so we'll call this one complete. Thank you very much for calling in or sending in your questions through the internet. This Glenn Gerberg Weather and Climate Summit is a very special opportunity for top scientists to interact with television meteorologists. And also, this is the second year now that we've opened up the floor and the questions to you, the online community. So we hope you join us back again tonight at 6 o'clock Mountain Time, where we'll bring you a funnier side of Jim Cantori at times, so Jim can share some of his amazing stories with storm chasing and his work at the Weather Channel. So at 6 o'clock Mountain Time, we'll start up the stream again. Until then, thanks so much for joining us. I'm Dave Jones with the Weather and Climate Summit, and we'll see you later today.